Hi everyone, this is Mrs. Foy, and this is a quick screencast about mole conversions with acid nomenclature. So not only do chemists know how to write and read formulas about acids, but we need to be able to do mole conversions. All right, good old mole conversions. So I'm going to get you started on this worksheet, and then you're going to finish the rest of it yourself, okay? So first of all, let's just remember that with a mole map, we know so far how to convert back and forth between the number of particles. So a particle can be an atom, or it can be a molecule, or it can be a formula unit. Sometimes we count ions. So it's whatever the particle is. And we can convert that back and forth to number of moles by using the conversion factor of 1 mole equals to 6.02 times 10 to the 23 particles. We can also convert from moles to mass by knowing the molar mass, right? So 1 mole equals, and then we have to calculate the molar mass. So you can use your conversion skills, your mole conversion skills, to be able to use this mole map and convert back and forth between number of particles and mass. That should all be reviewed for you. But now we're going to add it with acid nomenclature. We're going to add that skill with it. All right, so here we go. How many grams are in 7.9 moles of nitric acid? Well, I don't see any hydro, right? And so that means this is not a binary acid. So it's not a binary acid. So that means it must be an oxyacid. And I know that ic acids must have come from an 8 polyatomic ion, right? And so you're going to use your nomenclature cheat sheet that also has acids on it. And so I know that this is nitrate, right? I know that is nitrate. And I know that acids always start with a hydrogen. And so this must have 1 hydrogen. And so the formula is HNO3. And again, to be fancy, sometimes we write a Q to mean that it is dissolved in water. And that has to do with how the hydrogen protons break apart. All right, we're going to learn about that later. So the first thing we need to do, now that we have the formula, is to calculate the molar mass. So I have 1 hydrogen at 1.01 gram, and I have 1 nitrogen at 14.01 grams, and I have 3 oxygens that weigh 16 grams apiece. And so when I add all that up, I get the molar mass is 63.02 grams per mole. That's the molar mass of nitric acid. So if I want a single unit, I'm going to start with the single unit. I want grams, and so I'm going to start with my 7.9 moles, right? So what I'm doing here is I'm starting at moles and I'm going to go to mass, right? And so here I go. So I'm going to say 7.9 moles of HNO3. And then I'm going to convert using the molar mass. I want 1 mole on the bottom. So 1 mole of HNO3 is going to weigh 63.02 grams. And so I see then that my moles cancel, and I end up with grams, and I want grams. So that is it. That's all I have to do. And I'll let you do the math, and I'll let you get to the correct answer with scientific notation with correct sig figs. All right? And so your answer should be so many grams, and then you need to tell me of HNO3. All right? So many grams of HNO3. All right, let's try another one. So how many grams does 17.3 moles of hydrosulfuric acid weigh? Well, this one I can see has the prefix hydro. So a hydro something something ic I know is a binary acid. If it's a binary acid, I know it just is going to have hydrogen plus 1 other element. Well, clearly that is going to be a sulfide ion, right? That's where the sulfuric comes from. And so hydrogen is a +1, sulfide is a -2, and so hydrosulfuric acid is H2S, and then I'll be precise and say, well, it is dissolved in water, and that is what I write AQ like that, okay? So now I'm going to calculate the molar mass of hydrosulfuric acid. And so I have hydrogen at 1.01 grams times 2, and I have sulfur at 32.07, and so I add that up, and my molar mass for hydrosulfuric acid is 34.09 grams per mole. So now I want grams. I'm in moles, and so I'm going to write down what I want, 17.3, or what I'm starting with, moles of hydrosulfuric acid. And I know in this case, 1 mole of hydrosulfuric acid is 34.09 grams. My moles cancel, I'm at grams, and that's what I want, grams of H2S. So you can do the math. Make sure that you round to 3 sig figs and put your answer in scientific notation, and you should be good to go. All right, see you in class.